Hi guys, so today we're going to look at properties of radicals and rational exponents. So to review, we're going to look at some of our exponent properties that we did back in like Algebra 1. Okay, so if you remember with your exponent properties, if you are multiplying the same bases, then you add the exponents together. So this would be x to the 6th, y to the 8th. If you have a power to a power, that's when you multiply the exponents. So this would be x to the 4th, y to the 6th. If you have numbers if you have exponents in the top and bottom of that fraction, that's when you subtract. So I would do x to the 3rd, and then I typically say if the bigger number is on bottom, I just keep it at the bottom and subtract. So I would just do 8 minus 3. That way I don't have y to the negative 5 and then I have to move it. It's just a little easier that way. If both numbers in a fraction have that exponent, you would multiply that to both of them. So this would be x to the 6th over y to the 3rd. Same thing with that negative exponent, but remember, negative exponents will flip whatever has the negative exponent. In this case, both parts of the fraction have it. So I would flip both of those. They would both get that 3. And there's my value. All right. Now let's look at properties of radicals. Okay, so if you have the same radicals, you can add them together. So if you have 2 square roots of 3 and you add 5 square roots of 3, you have 7 square roots of 3. Okay, so you are able to add those when they're the same. When you're multiplying, you can obviously multiply the outside numbers together, but the square root of 3 times the square root of 2, you can multiply that, and that will be the square root of 6. And we're going to look at that property a little bit more today. Something else you learned about was how to rationalize the denominator. So you'd multiply by the square root of 2 on the top and the bottom. So square root of 2 times the square root of 2 gives us just 2. And then I have the square root of 2 left at the top. All right, so we're going to use some of those properties with what we do today. So we're going to start just looking at those properties with exponents. All right, so this first one, I have a power to a power, so I would multiply those exponents. And it's just a little bit harder because it's fractions. So this would be 27 over 8, and then I'm going to multiply 1/4 times negative 4/3. Those multiply together to get a negative 1/3. Again, negative exponents would flip the fraction. So this is 8 over 27 to the 1/3. So both of those numbers, we would take the cube root of them. So that would be 2 over 3. All right, then looking at this next one, I'm multiplying the same base so I can add the exponents. So this would be x to the 2/3. Let me go ahead and write it this way, 2/3 plus 5 over 9. And then my y's I can subtract, so this will be 2/5 minus 1/3. So then if I want to figure this out, I can get a common denominator, so I would multiply both of these by 3. So this would be x to the 11 over 9. The y's I can subtract, get a common denominator. This becomes 5 over 15. 6 over 15, so I get y to the 1 over 15. All right, so properties of radicals. So we just kind of briefly talked about that product property. Okay, you can multiply them together, but pay attention here, that n has to be the same. So normally we had just done square roots, but today we're going to look at cube roots and fourth roots. So that root has to be the same in order to be able to do this operation. Okay, it also works very similarly with dividing. Okay, so you can rewrite them as one fraction or as separate. So looking at A, these are both cube roots, so I can multiply the outside numbers, and I can multiply those cube roots together and make that the cube root of 72. Well, the cube root of 72 I can simplify using what we did yesterday. So a perfect cube that can come out would be 8. So then the cube root of 8 is just 2. 10 times 2 is 20. All right, looking at B, again, I can rewrite this as the 4th root of 80 over 5. So this becomes the fourth root of 16. And the fourth root of 16 is just 2. Plus and minus 2 if you want to be specific, but 2 is good for now. All right, so if you think you got this, try and pause it and then try C on your own. All right, so on C, then I can multiply. So this would be the cube root of 24 over the cube root of 2. And then I can divide, and that gives me the cube root of 12, and the cube root of 12 does not simplify, so I am done. All right, D, the cube root of 120. Again, using those same properties we did yesterday. So cube root of 120, I can rewrite that as the cube root of 8 times the cube root of 15. The cube root of 8 is 2, so this is 2 cube roots of 15. D and, well, like this is again labeled D, we'll call this E and F. These are probably the two hardest ones because this is going to combine our rules together. Now remember that if we have the same base, you can, and you're multiplying, you can add exponents. So like when I had x squared times x to the third, that became x to the fifth. Okay, but if I had x squared times, y squared times x to the third, I couldn't do anything with them because they're different bases. So on E here, I have the same base. Those are both 16s. So I can rewrite that. That would be 16, and I can now add the exponents because I had the same base. So 2/3 plus 5/3 is 16 to the 7/3. Well, now my two numbers, they have different bases, but they have the same exponent. So if they have the same exponent, I can rewrite them just with that same exponent. Now I can just divide. So this is 8 to the 7/3. Cube root of 8 is 2. 2 to the 7th is 128. And then at F, we're going to use a similar concept, but this one's a little bit trickier. So again, I can combine the tops and make that the cube root of 54. All right. But again, right now, that's not going to match up with anything at the bottom. So I'm going to rewrite what's at the bottom. I'm going to rewrite this as 2 to the 1/6 times 2 to the 1/6. Because now it's a little easier to see. I have the same base, so I can add the exponents. So that gives me 2 to the 2/6, which is 1/3. Well, 2 to the 1/3 is the same thing as cube root, so I can rewrite this as 54 to the 1/3. So now I have 27 to the 1/3, which is 3. Okay, so sometimes it's a little easier to rewrite these with rational exponents because it's a little bit easier to see some of your operations. But keep in mind, in order to add those exponents, you need to have the same bases being multiplied. Okay, the same base needs to be multiplied. All right, so when it comes to radicals, the rules we're going to follow in here in order for a radical to be simplified. It needs to have no perfect nth powers. And we say nth because it depends on what root we're talking about. So if it's a square root, no perfect squares. If it's a cube root, no perfect cubes. All right, and then we don't want fractions or denominators, no fractions in the denominator or fractions in the radical. All right, so let's look at A. So I could rewrite this as the fifth root of 7/8, but that's not really going to help me because 7/8 doesn't simplify. So what I have to do instead is follow a similar process that I did when I had 1 over the square root of 2. And I multiplied by root 2 over root 2. But instead of just multiplying by the fifth root of 8, that's actually not going to get me where I need to go. Okay, so I need to be a little bit more strategic about the number that I pick. So I need to think about what sort of a perfect fifth power number I have. Okay, so think about 2 to the 5th, 3 to the 5th, 4 to the 5th, what any of those numbers are. Well, we know 2 to the 5th is 32. It's pretty easy to get to 32 from 8. Okay, so if I multiply by the fifth root of 4, that's going to give me the fifth root of 32, which we now know is one of our perfect fifth powers. Well, if I multiply the bottom by fifth root of 4, I got to multiply the top by the fifth root of 4. So now this becomes the fifth root of 28. All right, so the fifth root of 28 is now over just 2. All right, so if you feel okay with this, try B on your own, and then pause the video, and then I will go ahead and go over this one. So this is the cube root of 4 over the cube root of 9. So an easy cube root to get to would be the cube root of 27. So in order to get there, I would need the cube root of 3, and that gives me the cube root of 12 over the cube root of 27, which is just the cube root of 12 over 3. All right, on C, I need to multiply by the conjugate in order to get rid of that square root. If I just multiplied by root 3, then that would still give me a square root. It would just now be with the 5. Okay, so I can't just multiply by a square root here. So you guys learned about multiplying by the conjugate back when you did like complex numbers, and you may have seen questions like this before as well. So I have to multiply by the same numbers with a different sign in between them. The reason I pick that, the reason I'm picking the conjugate, is because when you FOIL this out, okay, I'm going to do 5 times 5, which is 25. But when I do 5 times negative root 3 and root 3 times 5, then those are going to cancel out because basically this ends up being a difference of squares. So all I have at the bottom is 5 times 5 minus root 3 times root 3. So then I just have 5 minus root 3 over 22. All right, so again, if you feel pretty comfortable with this, go ahead and pause it, try D and F, and then we will go over the rest of these again. All right, so on D, I'm going to rewrite this as the 5th root of 3 over the 5th root of 4. So again, a 5th root that's easy to get to would be the 5th root of 32. So I'd have to multiply by the 5th root of 8 top and bottom, which gives me the 5th root of 24 over 2. On E, that's going to be a little bit easier to rewrite it as one fraction. Now that it's rewritten, I can simplify the inside. So this can become, I would subtract the exponents, so that would be x to the 8th, y to the 4th. And then remember to simplify these with the variables. We're looking for sets of 3 because it was cube root. So I can take out 2 sets of the x's. I'd be left with 2 x's. I can take out 1 set of the y's, and I'd be left with 1 y. On F, I got to multiply by the conjugate. So that is root 6 plus root 2. So that gives me root 6 plus root 2 over 6 minus 2, because again, the middle terms here will cancel. So it's just root 6 times root 6, which is 6, and root 2 times root 2, which is negative 2, because it was minus here. And that just simplifies to root 6 plus root 2 over 4. All right, on F, those are the same bases and the same root, okay? So this is something similar to what we did at the very beginning when you had 3 square root of 10 plus 2 square root of 10. They were both square roots and they're the same number in the square root, so we could add them together. So this can become 12 times 9 to the 2/3, okay? Because I have 4 of them. I add 8 of them, I have a total of 12 of these 9 to the 2/3 powers. And then finally on G, okay, again, in order to add them, they have to be the same root, which they are, but they also need to be the same number under that root, which currently they aren't. So I need to do something to simplify it to get it there. So what I can do is I can rewrite cube root of 40, that is the cube root of 8 times the cube root of 5, which means that is the same thing as 2 cube root of 5. So now I can add them together and I have 4 cube roots of 5. All right, so that is it for our properties. Again, just be careful with your differences between your roots and your radicals. and just be careful that you follow your correct rules on when you're supposed to add your exponents and when you're supposed to multiply your exponents.